this lecture, we will solve the systems of linear equations. On the left-hand side, this system consists of two equations with three variables x, y, z. The second example is that it has three equations in the system, and there are three variables. Now, let's look at the first one. The first one, we like to do is we like to eliminate z. Okay. But here is positive 2z, here is negative 2z. So we like to do is we multiplied the first equation by 2 everywhere, and then this negative 2z will come negative z will become a negative 2z. Then when we add those two, negative 2z, positive 2z will cancel each other. Okay, now here is the things I wrote. To eliminate z, the first equation is multiplied by 2 everywhere. And then add to the second equation. So the first equation multiplied by 2, 2 times 3x is 6x. 2 times 5 is 10, and then we have a y. And 2 times negative z is negative 2z. 2 times 8 is 16. And we want to add this equation into the second one. Then we have a 6x plus 1x, so we have a 7x. And then 10y plus 1y, we have 11y. And again, negative 2z with positive 2z, they cancel each other. And then we have 16 plus 5 is 21. So z is cancelled. Now we like to do here is that we want to use x to express y. Okay? So then both sides, subtracted by negative 7x. In this case, we will have a positive negative 7x cancel each other. And the left-hand side, we only have a 11y left. Okay? And the right-hand side is 21 minus 7x. Now, then both sides needs to be divided by 11. So 11 will cancel each other, and y alone on the left, right-hand side, it has 21 minus 7x divided by 11x. Okay, so y left alone, and the right-hand side is this one. So we basically use x to express y. Alright, so here we succeeded in using x to express y. Our second goal is to use x to express z. Okay. In the step down here is z is eliminated. Then we are able to use x to express y. And then our second goal will eliminate y, let y disappear, and then use x to express z. In order to let y disappear, here is 5y, here is positive y. So if here were negative 5, then when we add, y will be cancelled. Again, we need to use negative 5 to multiply the second equation everywhere. So what we get here is that to eliminate y, the second equation is multiplied by negative 5. and then add to the first one. Now, let's see. You know, negative 5 times x is what? Is negative 5x. Negative 5 times y is negative 5y. Okay? And negative 5 times 2z is negative 10z. And down here, negative 5 times 5 is negative 25. And then this one needs to add to the equation 1. Okay? And then we know negative 5x with 3x, so we then have a negative 2x. Negative 5x, negative 5y with positive 5y, we got nothing because they cancel each other. And negative 10z with negative z is negative 11z, right down here. And we have a negative 25 with 8, and then we have a negative 17. Alright? So then after this equation, this one, added to the first one, we got this one, and then we can use x to express z. How? Like what we did here is we need to move 2x negative to the right by adding 2x on both sides. If we add 2x on both sides, we then can cancel this positive negative 2x, and then here will be 2x minus 17, or negative 17 plus 2x. That's basically like this, 2x minus 17, or negative 11z on the left. Okay, those two again will be cancelled. Now we like to do is both sides multiplied by negative 1 first. Okay, you will see the reason. You see, if we multiply it by negative 1, then negative is positive 11z. And then negative 1 times 2x is negative 2x. Negative 1 times negative 17 is positive 17. Then we do both sides divided by 11. Okay? And 11, they cancel each other. So we then have a z on the left. Right hand side is then negative 2x plus 17 divided by 11. Okay? So then we, like we did for this one, y is expressed by x and z is expressed by x. And x is itself. So then we can see that here will be what? Will be x is x, and y is this one, z is negative 2x plus 17 divided by 11. This tells us for each different x, if you put x is 1 here, then you then have a what? You then have a value 21 minus 7 times 1 divided by 11. And you then have a z equals negative 2 times 1 plus 17 divided by 11. You have one solution, a group of solutions for x, y, z. You did for x equals 1, you can do for x equals 2, x equals 3, x equals 4. Then in this case, this equation has infinitely many solutions. Okay? Alright. Now, we are okay with the first one. Now, how about the second one? The second example is that we want to do is we want to eliminate x in equation 1. Okay? So to eliminate x in equation 1, we can see here is positive 5. We need negative 5x. So we multiplied the third equation by 5 everywhere, then you know when you add, this negative 5x will cancel this positive 5x. Okay? So we multiplied 5 to equation 3. What do we get? We get this. 5 times negative x is negative 5x. 5 times negative y is negative 5y. And 5 times 4 is positive 20. 5 times 4 is 20. Okay. Now we want to add this one to the first one. Negative 5x, positive 5x, they cancelled. But we also see negative 5y cancel positive 5y, and 20z cancel negative 20z down here. Huh? And here, 20 plus 8 is 28. So right-hand side, we have 28. Left-hand side, we have all cancelled, which is 0. So what we get is 0 equals 28. That's ridiculous. So it is a contradiction. Okay? Then what can we conclude? We then conclude the system has no solution. Okay? Yeah. So when you reached a point that a ridiculous conclusion, a ridiculous equation, you then can conclude that. Okay? Please review those examples. They're very typical. One is it has infinitely many solutions, like here. Another is a contradiction, so system has no solution. All right? I'll see you next time.